Take us away, Don.
Right. So, good morning. A little bit about what TBGA and kind of how we got connected to Velo is that we're an engineering firm and we specialize in advanced manufacturing and additive manufacturing. So we have a group of engineers, and we came in contact with Velo3D a while ago and started a relationship to kind of help them through this process with different customers. Yep. So what we have is experience qualifying and using the equipment, and I think that was of great value to Will and Zach and the team. So what we do, like I said, we're an engineering firm. We have consulting solutions. We do training as well. So we help from the CEO down to process engineers. And we also have a communications business to help basically people tell their story in additive manufacturing, because there's many different stories to be told, and we try to help find that voice. We also have, I'll mention our online training program that we have through Purdue University. So if you, anywhere in the world at any time, you can take this course, and it kind of gives you the basics of additive manufacturing.
Excellent.
Okay. So we very often come across people who, think they're experts in additive manufacturing, and we bring up that there's 7 forms of additive manufacturing. So sometimes that's new, sometimes it isn't. Specifically, this morning we're going to be talking about powder bed fusion, which is highlighted in blue.
Gotta be careful with there we go.
Yeah. So that's where Velo's product sits. It's a type of powder bed fusion process. And so very often we find ourselves in a situation trying to help people, work through an additive problem, which is really a production problem, which is really a business problem. And I think more often we're seeing a lot of the attention come to solving, how you're actually going to make money with additive manufacturing. It can't just be because it's cool or new or whatever. So we go back to the tried and true trade-off curve, looking at how many parts you're going to make and the cost per unit. And so traditionally what we look at is that there's always going to be a break-even point between a legacy manufacturing process and an additive one. The slopes are different that we represent in terms of learning curves. And because it's a more lean process, we assign it a more shallow learning curve. So as a basic principle, at some point, your conventional manufacturing process, because of tools and things like that, is non-competitive in low rate production. And at some point, additive manufacturing will always be a good solution. But we really try to work with people to fully appreciate this complicated story. And it really goes back to what your product requirements are. This is a problem that's been solved many times before. So where we found a similar spirit with Velo was that this is a problem that people need to understand. And if you don't understand how the machine works, you don't understand how to make a business case, ultimately you're going to be really difficult time getting the rest of the way. And so generally, people ask us, well, what's going on? People don't get to come to a conference like this. So we generally see that more machines are being sold. If you look at historically, the trend is going up. Velo came into existence really in 2014, but we were very quiet.
We were in stealth mode for the first 4 years, and then came out at IMTS with our machine printing parts when it was available right there. So it's been a very interesting year. First, at the beginning, people didn't believe we could do what we're actually doing, and now people are realizing that, and really we've at this point, and we'll see this in the next few slides, how we're working together with the Barnes Group advisors to really not only have a machine that can do the impossible, but also make the economics work as well.
Yeah, and so I think that the concepts are faster or more productive or integrated systems. So we're seeing people who are looking at, how do I make a factory of machines? How does it get introduced into a manufacturing process? Some companies are just more consumed with trying to go faster. And a lot of times that just represents itself in more lasers, which kind of perpetuates kicking the can down a road a bit. But so I think it was interesting when we got introduced to Velo that really there was a hybrid approach that was going on there. And I think that's what is kind of very compelling about the story. Yeah. So kind of pursuant to that, we like process economics. We like to talk about the financials. And so to help kind of demystify the process, we ghosted some parts. We went through different processes to kind of give people a view of how does the process stack up as you look at the different types. So specifically today, we're kind of worrying about laser powder bed fusion. And what we always hear people talk about is, oh, well, the powder is expensive, but it's only 10 to 14% of your problem. Probably not the thing to worry about. You know, when you look at the printing time, processing time, that's the majority of your cost. So really more attention. If you spend more time there, you'll do a better job. This isn't true though across the different forms of additive manufacturing. That's all we're trying to highlight here, is that what's true in one technology doesn't necessarily hold true for a different one.
Yeah.
So to that point, you know, if you wanted to figure out how to get some cost out of your process, you know, where is it? If it's in the printing time, you know, one way to look at things is go to thicker layers. And we see this as a trend in the industry currently. So thicker layers will mean less resolution. However, if you go to thicker layers, you're also dramatically cutting into your print time, therefore your actual cost. So in this chart, all we've done is basically plotted out moving up to thicker and thicker layers can reduce your part cost. So we've resolved it now to a part level, not just the print level. So you can see by going up to, you know, a 90 micron layer, you can actually get the cost of the part down 25%. You know, the same wouldn't be true if you just focused on powder, for example. So it would give you a very small percentage of the overall cost reduction. So this is just a highlight of, if you know more about your process and how it works, that's where the money is, literally.
Yeah, and so then also you can see right here how Velo is plotted up against the other kind of more industry standards. So we generally use 50 micron layer parameters. So everything you see in the booth today is basically 50 microns. So it's this balance of material properties, surface roughness, surface quality, and throughput. So where we found the sweet spot to be is right at 50 for now. For now.
So very commonly you hear people talk about design for additive manufacturing, and you know, this is a highly charged phrase today, and it means different things to different people. However, so why do people talk about it? And it goes back to this notion that the print time is important and the post-processing is important. It's about 80% of your overall cost. So design really can impact all of those things. So when we look at the stack up again, you know, it directly impacts your printing time. It directly impacts your post-processing time. So basically about 86% of your part is really driven by your design. If you don't get that right, now your 86% is now in play. And to highlight that point, we produced our logo here on a traditional system, and you can see when we're blazing through and we're making a solid, you can see how, while it's a fast process, it's not fast to watch. And I usually make it very painful for you to watch, to make it very slow. However, we're going to go into a honeycomb section, and you can see how much more quickly we cover the same space, but with a honeycomb, we can do that in much shorter time. So this is a critical point that most people don't get when looking at designing for additive, which is that it isn't necessarily about lightweighting the part, but a lighter part is also faster to make, and therefore it's cheaper to make. So this is why, you know, this is kind of a simple illustration of why design for additive does have some benefits to really think about. And it's no different from any manufacturing process. If you don't know how the process works and you don't design for it, you will struggle, you know, to get a good cost impact.
All right. So now we took this input of really how do we break down the process economics to really and make a large impact. So at this point, you've lightweighted your part, but you still have a part and you still have some supports that you have to work through. So we have right here our traditional 10-degree impeller. You can see at the top, it's width supports, how it'd need to be printed on a conventional metal AM system. And then below you see the VELO3D solution, which is really only, there's a support here that's really on the outside of the perimeter. So when the part's taken out of the machine, then you chuck it up on a lathe, you can spin out that, cut off this OD here on the lathe. So you can see first off that really dramatically reduces the post-processing time. So it's actually 89% less surface area to machine. And additionally, it's not only 89% less surface area, but you'd actually have to be going in with a ball nose cutter or some sort of very slow, complicated machine in order to actually go in and remove the supports and machine out the center of the impeller. And then also looking at the relative printing speed, so it's about 20% faster on a Velo machine. So this is a back-to-back analysis of looking at the exact same geometry with supports and without supports. And one other key thing is we talked about the 50 micron layer thickness, but additionally, we're generally working with full kilowatt per laser for our standard core process. So really a very high throughput, not just saying that we have 1 kilowatt spec'd out on our machine, but we use that day in, day out as our best process. And then finally, we have coincidentally 14% less material on this part just from having less support. So it's helping you all the way throughout this the manufacturing. One, less powder you're paying for, less time lasing, and then finally less material to remove. So having the support-free technology really improves the overall business model of the part being an additive to begin with. And then we're going to walk through just a little bit more of like, let's take this to the next level and let's start thinking about serial production for metal AM and how can we impact this on the design stage. So for us, we're going to first look at a case study. This is a case study we worked with the Barnes Group a few months ago to really look at how our system, how the VELO3D Sapphire system rolls up to a standard incumbent system with a 250 millimeter square build plate. So right here, you can see this is a turbine blade. There's 80 parts per build. And then looking here, we're actually able to free float parts if it starts from a single point. So this is similar to what you see in SLS technology, where you literally can pull the parts straight out of powder. And I'm sure you can see over there on the video loop, somewhat pulling these parts straight out of powder. But really, it impacts this from going from 80 parts per build to 450 parts per build. But then additionally, it goes from a 2-day build to a 13-day build. So far fewer changeovers, and then also those nights, weekends, you have less downtime. So your overall machine machine utilization goes up dramatically. And then looking at how does this impact us when you get outside of the printer? So you can see on the top, on the left, from the left to the right, you go from the printer to a thermal treatment, just to heat treatment in order to reduce the residual stresses before cutting it off the wire or cutting off the build plate with wire EDM, and then finally some support removal. And then additionally, that build plate that you just cut off, that has to then be refinished and then eventually checked just to make sure that it's hasn't warped too much, basically. And then finally, HIP and solution age and machining. You can see basically with our free-floating technology, you can short circuit this entire system. So you take the part out of the printer, the residual stresses are relieved when it goes through the solution age steps and the heat treatment over here. So really you're taking the part from the printer to thermal treatment and then final machining. So it's a dramatic decrease in the number of steps, the shop operations. And really when you start eliminating entire steps out of your supply chain, it really benefits in terms of throughput, getting parts out the door, less stress, less tracking. So this was an excellent study. I'm happy to present it here where Kevin and Chelsea on John's team actually we worked together. They did the system roll up on the incumbent system, and then we fed data back and forth basically to really give a true apples to apples comparison of how a standard 250 millimeter system would build this exact part. You can see right here in the lower left, there's a standard spacing, the part orientation, all of this was taken into account. We really tried to make sure that we got as accurate as possible with the data we had to really have a proper back-to-back comparison. And then you can see with the Velo Sapphire system, we can do 80 parts per build if it's on the build plate. And then we have this free floating option as well with 450 parts per build. And you can see basically from the system the incumbent system today, it's about $500, and it actually goes down to $340 right here as we step through. So it's a pretty dramatic decrease in the overall cost of the part. You can see part of that's in the printer, but also outside of the printer, you can really impact the cost of the parts. So this is, when we think about the overall, this really helps us to kind of recalibrate ourselves of, okay, it's not just about one system price versus the other, and that's going to dictate my part price. It's really, how does this affect your shop operations? How much throughput can you get through that machine? And that's where the Sapphire system really starts to stand out.
And I think for us, just having that whole of process perspective, is a productive conversation because it's not common. And so we there's a number of things that went into this, and including looking at how we, place those parts. And when you have to put them at an angle because of your recoder blade, sometimes that might mean that you make fewer parts. In the Velo system, we've got a contactless recoder, so that allows a little bit more flexibility there. So all the stuff that I said about DfAM is less important here, but still important. But I think that's what we like about it, is that this kind of has the production engineer in mind.
Yeah.
When we're looking at parts and how to make those parts.
Yeah.
So hitting the home stretch, again, we just go on about the business case, routinely, and really in our conversations over the last day, the conversation's moving more and more towards how are we going to make money using additive manufacturing. And it all starts with the business case. It always has started with the business case. It always will start with the business case. So, we like to look at the holistic process. We like to have that inform how we use the tool. At the end of the day, it's a printer. It's part of a process. It's a tool. And we really need to know how that process works in order to design for it appropriately, and then, make a better business case and really get to more, get to a higher profitability is what the metric is at the end of the day.
Great. Excellent. Well, thanks, John. Thank you very much for your attention. Real pleasure presenting with John Barnes. Thanks for coming over.